Hi everyone, this is Shruti from Programming Club of IIT Madras. So today we'll be looking at the editorial for Codeforces round 820 division 3. So let's start with problem A. Lad went into his apartment house entrance. Now he's on the first floor. He was going to call the elevator to go up to his apartment. There are only two elevators in his house. Vlad knows for sure that the first elevator is currently on the floor A, that is motionless. The second elevator is located on floor B and goes to floor C, and B and C are different. Please note if B is 1, then the elevator is already leaving the floor 1, and Vlad does not have time to enter it. If you call the first elevator, it will immediately start going to the first floor 1. If you call the second one, then first it will reach floor C and only then it will go to the floor 1. It takes mod of x minus y seconds for each elevator to move from floor X to floor Y. Vlad wants to call an elevator that will come to him faster, help him choose the elevator. So here we have the input and the input format. So what are we supposed to print? We are supposed to print 1 if it is better to call the first elevator, 2 if it is better to call the second one, 3 if it doesn't matter which elevator to call. So let us see the problem now. So if the first elevator is at floor A, then we need to compute the time taken for it to reach first floor. So if it is at the second floor, then it takes 1 second, that is basically mod of 2 minus 1 and so on, right? So for T2, say the time taken for elevator 1 is nothing but mod of A minus 1. And now we will compare with the second elevator. Now the other cases, we have two cases here. When C is higher than B, then the elevator will go up to C first and then it will come from C to 1. So we need to calculate the journey upwards plus the journey downwards. So first journey takes mod of C minus B plus mod of C minus 1, right? So since C is above 1, B is what we've assumed, we can take this mod and this mod as well. And we can write it as 2 times C minus B minus 1. So this is the case when C is above B, which is nothing but C is greater than or equivalent to B. Now let us say that C is below B. Then C, B and 1. So basically it will be mod of B minus C plus mod of C minus 1. So we can remove the mod here because B is greater than C. So B minus C plus C minus 1. So you can view it as it is just traveling from B to 1 as well. So the time is B minus 1. This is our T1. So based on the value of C, we will calculate our T1 here and then we will compare T2 here. Whichever one has a lesser one, we will go for that particular option. And if both are same, we will print 3. So let us look at the code. So I've declared A, B and C and I've declared T1 and T2. So if C is greater than or equal to B, T1 is 2 times C minus B minus 1 and T2 is A minus 1. In the other case, T2 remains same A minus 1, T1 becomes B minus 1. So if T2 is greater than T1, then we output 2. Basically, if T2 is greater, means 1 is taking more time, so 2 is better. And if T1 is better, that is, if T1 is greater, then first lift is better. So we will output 1. And if both these conditions are not true, then T1 equals T2, so then we will output 3. So yeah. So now let us look at the B problem. Polycarp has a string S consisting of lowercase Latin letters. He encodes it using the following algorithm. He goes through the letters of the string S from left to right, and for each letter, Polycarp considers its number in the alphabet. If the letter number is a single digit number which is less than 10, then just writes it out. If the letter number is a two-digit number greater than or equal to 10, then it writes out and adds the number 0 afterwards. So if it is C, it corresponds to 3, which is a single digit number, so we just add 3. O, 15, which is a two-digit number, so the code becomes 3150. D, it is 4, so it is just 31504. E, 315045. So now you are given the string T resulting from encoding string S. You are supposed to decode. So we are given the number code, we are supposed to make it the letter code, the original string basically. So now these are the sample test cases. So now let us look at the problem. So given the code encoded string, we could start looking at the string from either the left or the right. Now looking at the string from the left is kind of ambiguous because here initially without checking for this particular 0, this 3 could correspond to either a single number 3 or 31. Here we do not have 31, but see we have a case where it is 215045. So in that case it is AODE. But by just looking at the first two characters, I am confused whether it is 21 or it is just 2, and then I have to check for zeros consecutively. So to avoid this problem, we could start looking at the string from the reverse. So here when I start with 5, there is no 0 before it, so this 5 has to be corresponding to E, because if it were was the units digit of a two digit number, then I would have a 0 here, but that was not the case. So this corresponds to E. Then I move my pointer to 4. So 4, the preceding number is not a 0. So this is definitely a single digit number and this corresponds to 4, to D. Now I'm encountering a 0. So what? So now I know that definitely there's a two digit number to the left of it. So I will consider the next two characters to the left, and that is 15. So now I know that 15 corresponds to 0, sorry, to O, and 3 is the only digit left, and the previous digit is not a 0. So this is definitely a single digit number, making it C. Now I think if I solve the test case 7, which is 5 ones followed by 2 zeros. So let us solve that case. 1, 2, 3, 4, 5 followed by 2 zeros. So the first time I'm going to encounter a 0. I know that it is going to be a two digit number. So I'm going to consider this initially. So this is 10. So 10 I know is J. Now I come to 1. I'm skipping these two and I'm moving here next. So here 1, there is no 0 before it. So definitely this corresponds to A. Here again the same follows A, and A. Say we solve the problem from the beginning initially. 1, 2, 3, 4, 5, and then 0, and then 0. So 1, say I look here, there is no 0. So I'm taking it as A itself. And then this, there is no 0. So I'm taking this as A itself. Here, also again, I'm seeing that there is no 0. So A here. So here I'm looking at it as a 0 here. So what will I do? I will consider this as a two digit number and this corresponds to K. And now I'm left with two zeros here, which does not make sense, and we cannot look for consecutive zeros all the time. So I think it would be a better approach if you could start from the reverse, and we are guaranteed to reach the right answer. So let us look at the implementation. So I'm inputting the string s and n. So s1 I'm declaring it to be the empty string which I'm going to build. So I'm starting from I is n minus 1 to I is positive. Like, and I'm making sure that it's greater than or equal to 0. And if s of I, I'm encountering a 0, then I'm taking the tens place which is n1 and the units place which is n2, and I'm making a character c which is the corresponding alphabet, which is a1 plus n1 star 10 plus n2, which is the number minus 1 because a corresponds to 1, so we need to add something more than a. So for b I will add 1 more though it corresponds to 2. So s1 dot pushback c will append this character to the string. I am here decreasing I by 3 because I is 0. I've already taken into account I minus 1 and I minus 2. So I need to move by 3 places. Say I do not encounter a 0, then it is simply a unit, it is just a single digit. So I will just do s of I minus 1 and I will add it directly to a. So this a, you could make it 0 here and subtract 1 here, anything works. So s1 dot pushback of the same character. So, and I'm decreasing I by 1 because I've just used one digit here. Note that when I'm starting from the reverse, I'm adding the digit from the left. So my S1 is reverse. So I'm using the reverse function to reverse my string and I'm outputting it. So yeah, thank you.
Okay, hello. So this is Sean here, and today I'll be sharing the solutions of problems C, D, and E. As we can see, this is my Codeforces IDE, and I've solved these 5 questions today. I guess we have went through A and B today. Now I have to explain C, D, and E, like how I solved it. So first, let me just go through the question C. The question C states that we have been given a string, and the string, a string of characters, lowercase Latin letters. Now we'll be hopping from the first child to the last child, and the cost of and we can hop onto in between tiles in random order. So one thing that we should understand from reading this question is that there is nowhere it is mentioned that we have to continuously jump forward. Okay, this is not mentioned. So we can jump backward also here. And the cost of jumping from ith index to jth index is given by index I minus index si minus index sj, where index c is the index of the letter in the alphabet, like index a is 1, b is 2, and so on. So we can read this question, and one more point is we can visit each tile at most once. Now, what do we have to find? Now let's just write the first test case which was given, which is logic. I'll explain using this. So yeah, the first, this is logic. What they have given us is they have given us a character, a string, and with this string, what we have to do is we have to tell that how can we go from the first position to the last position using, first thing that we have to do here is minimize the cost. And after minimizing the cost, okay, after minimizing the cost, what we have to do is maximize the moves. Okay, maximize the moves. So we have to do these two things together: minimize the cost and then maximize the move. So for any string, we can see the cost will be given as, suppose I move from index I to index I1, I2, and so on up to IN, IK, and then I move to my final index F. Okay, so this is from I to F. F is final index. Okay, F is the final index, and I is the initial index, first index. From the initial index to the final index, this will be my path. Now what will the cost be? It will be I minus I1 plus I2 minus I1 okay, not this. Basically, let me write hash. Let me define hash I is the index value of si. Like in this case, hash 0 is what's the position of L? L is, I guess, 12. So hash 0 is 12. Hash 1 is the position of O, which is 15. Hash 2 is the position of G, which is 7. G, yeah, G7. Hash 3 is the position of I. Position of I is 9, and hash 4 here will be 3. So this is what I mean by hash. So this will be mod of hash I minus hash I1 plus and so on up to hash of f minus hash of ik. Now I want this to be minimum. Now when will this be minimum? So let's first discuss the minimum case, right? So if I move from I to f, I can see that my cost will be hash f minus hash I, right? Hash f minus hash I. And this path, if I just open the mod, we know a minus b mod is greater than equal to a minus b. We know this mathematical formula. So when I expand this, this will be hash, like let this be s. So s will be greater than equal to hash I minus hash I1 plus and so on up to hash f minus hash ik. Now we can see that this I index, everything will get cancelled in between, because the middle terms are something like hash I2 minus hash I1, hash I3 minus hash I2, and so on. These are the middle terms. So they'll get cancelled off, like I2 will get cancelled with I2, I3, and so on. This will become a telescopic series. So my S is greater than equal to hash F minus hash I. Yeah, hash I1 minus hash I. So this will be hash F minus hash I. And so basically the minimum value that S will have is hash f minus hash I mod. Like the minimum value will be this. So now we need to, so we got what the minimum value is. The value can't get minimum than this. So we know that minimum value is this, and we know that this is achievable. How do you know it is achievable? We'll just go from the first index to the last index. Like the direct jump from year to year. So that is how it's achievable. So this is the minimum cost. So we got one answer. Another thing is minimum, we want the maximum moves. Okay. Now let me tell you an algorithm how we'll move in general. Suppose your final index is greater than your initial index. Okay, greater than or equal to your initial index. Like in this case, logic. Okay, like in case of logic, this works perfectly. So logic, the sequence is 12, 15, 7, 9, 3. Okay, 12, 15, 7, 9, 3. So the way you move is first you take 12. Okay, you put an index. What you do is you print out its index, so its index is 1. Then what you do is you move on to the nearest index to 12 towards the direction of 3. Like now, since 12 is greater than 3, we'll move towards 3 and look at the nearest value to 12. So nearest value to 12 towards 3 is 9. Okay, so if there was an 11, the answer would have been 11, but there is no 11. So now next move will be towards 9. So we are going to index number 4. Now they are expecting us to answer in a one index array, not a zero index array, because we can see the test cases are such that they have written here that the first number in the sequence should be 1, where we have to print the sequence of indices. So it is one index array. So yeah, this is first you put 1, then you put 4. Now from 9 you go towards 3. From 9 you are going towards 3. 9 is greater than 3, and now from 9 we are moving towards 3 using a value which is nearest to 9. So nearest to 9, now we have 7, which is index 3, and then from 7 we have no one in between, like 7 and 3, so we directly go to 3. So this is our path. This is our path. Okay, and this matches well, right? So did you get the logic? The logic is the way we minimize. The way we minimize here is we minimize using we minimize such that we go in either descending or in ascending order. If your final is greater than initial, then you go in a descending order. If your final is less than initial, you go in ascending order. Like in for ascending order example, you can see Codeforces, a string name Codeforces. So this is 3, this is 15, 4, 5, 6, 15. R is 18, C is 3, E is 5, and S is 90. So these are your numbers. Now you have to go from 3 to 19. So from 3 you will jump to another 3. From 3 you have to go to the next nearest, which is 4. Then from 4 you'll go to 5. From 5 you won't go to 5. Okay, let me just show my screen. I'm sorry for that. Yeah. Now for that we'll look at this Codeforces string. I just wrote down all the value indexes here. So this is 3, 15, 4, 5, and so on. I'll repeat this once again. So yeah, from 3 you will go to the next nearest one, which is 4. Sorry, from 3 you will go to the next nearest. So the next nearest to 3 is not 4. We are going from 3 to 19. So next nearest to 3 is a 3. Then from 3 next nearest is 4. From 4 next nearest is 5. From 5 again we have a 5. Okay, next nearest is 5. Then from 5 we go to 6, and from 6 we go to 15, then back to a 15, and then from 15 to 18, and then from 18 to 19. So if you carefully look, this is the path that they have suggested. You go from 1 to the 8th index, then 3rd, then 4th, and so on. So this is what they have suggested. And from here the minimum cost is 19 minus 3, and the moves that we did, the maximum moves that we did will be the maximum steps we took will be basically all of this. So those are the 10 indices. Now let me show my code here, which will clarify how I basically implemented this. So this is the code for the C question. Now initially what we do here is we input the string s, we check its length, and then I make an array of positions. Okay, so this is a vector, this is a vector of arrays. Okay, where position I, okay, so this is a vector, this is the array of vector. One second, this is an array of vector where position I stores the indices, stores the indices, yeah, stores the indices of numbers, stores the indices of character a plus I. Like a will be stored in position 0. Like wherever a occurs, that will be stored in position 0. Wherever b occurs, that will be stored in position 1, and so on. Like I'm making a 0 index array, so this will be stored in position 25. So this is how I'll store my positions. So this is what my position array is. Then from this is how I'm storing. Okay, so from I is equal to 0 to n, I'll iterate to this, and then I'll check. Now if my ith index, I'll push back my ith index into this position si minus a. So if si is, so if my si is suppose c, then position of c minus a will be pushed back with the ith index. So c minus a is position of 2. Okay, so position of 2 will contain the index wherever c occurs. Okay, then this is my start, this is my end. If my start is greater than end, okay, so if my start is greater than end, it's like this case I'm talking about. This case, if my start is greater than end, I'm referring to this case. What I'll do is I'll first print out SO minus S0 minus Sn minus 1. This is my minimum cost. Okay, I haven't used absolute here because I know S0 is greater than Sn minus 1. Then initially I'll initialize my moves to 0, and then how I'm moving, like the way I'm moving is, as I told you, suppose I'm moving from 15 to 3. So first I'll go through all the 15s. Okay, like I'll go through all the 15s. Now, since my case is that this is strictly greater than this, right? 15 is greater than 3, something like that. So So what I'll do is I'll first check all the 15s, then all the 14s, all the 13s, and so on, all the 3s. Okay, this is how I'll move. First, if I have 15 year, 15 year, and 15 year, then a 14 year, 14 year, then some, like suppose I'm just jumping forward, I have 7 year, 7 year, a 3 year, and a 3 year. So my moving strategy would be first I'll cover up all the 15s, then I'll cover up all the 14s, then I'll cover up all the 7s, then I'll cover up the 3, and then I'll go to my final index. So this is how I'll move, right? So how many moves am I going to do? How many levels am I going to step on? So this will be number of 15s plus number of 14s plus number of 13s plus and so on to number of 3s. I won't miss any of them because I'm traveling all the numbers from 3 to 15 here. So basically the number of moves that I do will be the count of, they will be the size of the position from start to end. Like number of threes plus number of fours, number of threes plus number of fours plus and so on to number of 15. In this example, like in this example, I'm moving from a 15 to a 3. Like from initially S0, S0 has the index 15 and index value 15, and S final has the index value 3. So in this case, I'll be, my number of moves will be number of threes plus fours plus and so on to 15s. So that is basically the size of this. And then I'll just this is I'll just count how many moves I have. So then I'll see out move, and then this is how I calculate move. And in case yeah, in this case my start is greater than end. So in this case my start is greater than end, so I'll have to go from start to the end, so I have to decrease my I when I go from start to end. Okay, so from 15 to 14 it's like 15, first I'll check for 15, then 14, then 13, and so on up to 3. Okay, in the other case I'll start, if I'm going from 3 to 15, then I'll increment my I will first be 3, then 4, and so on up to 15. So here it is I plus plus, here it is I minus minus. That's the only difference between the code where s is greater or s is lesser. And yeah, that's it. Now how do I print the path? The path is I go from start to end. Okay, and then I'm printing all the value, all the indices where 15 occurs. So this is basic. Now it doesn't matter in which order I traverse them. So I have printed them in that in random order. Like in this example, 15 7. In this example, we could have traversed it in any order, like this 15 7, 15 7, 15 15 7 3. Suppose this is your array, you can traverse this way, you can go this way, or you can go this way and come back. Like it doesn't matter, you can do both of them. Okay, so yeah, that's the explanation for this code. Yeah, I hope you understood it. Yeah, thank you. So let's continue with problem D here. uh, the statement of problem D is this: like there are some n friends, uh, and each friend has some money. Burls imply money here. So they have x, they order for xi burls, and they total have yi burls with them. So the ith friend has orders for xi burls and has yi burls with them. So the person whose xi is more than yi is basically ordering for is basically ordering more than he has. Okay, and the person with a higher yi than an xi has more money than he's ordering for. So this is something we should understand. And for the people who have xi equal to yi, they're ordering for the exact one. Like they're ordering an item which has the cost xi, and that is equal to the amount that they have right now. So this is basically what we can understand. There are three cases possible. Now then, uh, they have told that the problem statement states that the friends decide to visit restaurant in several days. Like some friends will go on day one, some other set of friends will go on day two, and so on. And each day at least two of them should go to the restaurant, and like at least two of them should go to the restaurant. and we want their bill, like whatever the bill comes, the bill should be less than or equal to the amount of money that they have. Okay, it should not happen that they don't have the money to pay the bill. Yeah, basically that's the problem statement, and we have to maximize the number of groups that can go. One more thing here is that the groups that they go in do not intersect, so it's distinct groups. So let's let's understand it once. So the best we have to first thing is we have to maximize the groups. Maximize groups. So how do we maximize the groups? The first thing how we can maximize a group is they have told at least two should go, right? At least two should go. So if at least two should go, we can make this exactly two should go. Like every time, every time there will be just two people who will be going. Okay. So this will basically maximize our chances. How will it maximize? Suppose instead of two, suppose you have two group. Suppose you have some 9 people. So the groups can be two, and one person will be left out. Now nowhere in the problem is written that every person should go. Okay. Nowhere in the problem statement it's written that every person should go to the restaurant. Especially in the first test case they have written, it can be shown that they will not be able to form groups such that at least two friends will pay. So in the first example itself, it occurs that everyone can't go into the restaurant. Okay, so I'll explain the first example also. So it's basically we should go in pairs of two. Now the other thing is that we'll just split them into three people. One will be where xi equal to yi, which are the good friends. Then there are some rich friends whose xi is less than yi. And then there are some poor friends, or okay, let's go with some other word. Then there are some friends, let's just go with friends, where xi is greater than yi. Okay, so these are the three categories which we have. Now for the first test case, let's just go through the numbers. It is 8, 3, 9, 2, 4, 5 for xi. Yi is 5, 3, 1, 4, 5, 10. Right. So I've written this down. Now let's put good R and okay. Let me just write this as profit. Now these people are the profitable people, and these are the lost people. Okay, so this is good, which is they just equalize themselves every time. There are some profit people and there are some lost people. So in this case, this person will be good. Okay, this 8 5 will go in loss. 8 comma 5 will go in loss. 3 comma 3 will be a good person. 9 comma 1 again a loss. 2 comma 4 a profit person. 4 comma 5 a profit person, and 5 comma 10 a profit person. Now how will we make groups here? Now the most optimal way of making groups will be, first I check if I can now first thing that I have to do is I have to put this person somewhere, right? I want this person to go somewhere. I want this person to enjoy a meal. I want him to go to a restaurant. So what I'll do is I'll look at the minimum way I can minimum okay, first I'll do what I'll do is I made these three groups, right? Now the good person can go with anyone because he does not need any money, right? Now profit people, they can also go with anyone, as they also don't need any money. But the lost people are such that they need they need one profit person, such that he or she can pay the bill, pay his or her bill, whatever, pay his or her bill. So these are the people that we have to focus upon, the lost people. Now, what we'll do is we'll store count of good people. Then what we'll do is we'll store the profit that each profitable person generates. Third, we'll store the loss that each loss person generates. Okay, like here, the values that will be stored in the profit array would be, here he generates a profit of 2, 4 minus 2 is 2. He generates a profit of 1, 5 minus 4 is 1. This generates a profit of 5, 10 minus this is 10 minus 5 is 5. Here the loss generated is 8 minus 5, which is 3. Here the loss generated 9 minus 1, which is 8. So what we'll store is the count of good. Count of good is 1. The profit stores in value 2. What is the value? 215, 2 comma 1 comma 5, and loss stores in the value, loss will store the value 3 comma 8. Okay, so how will we proceed is, first thing that we'll do is we'll sort our profit and loss arrays. So what finally we'll get is, this is basically count. Okay, so this will be 1, this will be 125, and this will be 38. Now what we will check is, now can this minimum loss minimum profit guy go with this minimum loss guy? If yes, then just send them. Okay, if the minimum profit guy can go with the minimum loss guy, then just send them. If he can't go with that, like in this case we can see that the minimum profit guy can't pay the bill for the minimum loss guy. So in this case what we'll check is, if good count is positive. Okay, so if there is some good person, what we'll do is we'll just put this profit person with the good person. Okay, so we'll pair these two up. Okay, so we are not wasting a profit person here, right? This person can go with anyone. So we'll just send them with this in for this case, because it can't go with the lost person. And if there are no good person, if there is no good person, then we'll just pair these up. We'll just pair these up. We'll just pair them. Profit with profit. Okay. Now how is this optimal? This is optimal because in every step, we are choosing the best method. In every step we are choosing the best method, and we are maximizing and we are maximizing the groups. Okay, since we are choosing only two people, we are maximizing the groups in every step. So basically I'll just repeat the algo. The algo is, if there is a profitable person there, if there is a profitable person there, and he can satisfy that lost person, satisfy bill for lost person, then just pair them up and send them to the hotel. Else, if they are not able to, if it is not, if he is not able to satisfy for the bill, then pair profit with good person. Good person is the one who can pay his own bill. So what we are doing is, we are optimizing, we are putting him with someone who, like, we are pairing him with someone who is like basically not demanding anything, right? So we are not wasting anything in this step. So if this step also is not possible, then what we do is we pair the profit one with the next minimum profit guy. Why minimum? Because that's the most optimal case here, right? If we pair, in this case, in this example, if we pair 1 and 5, like, let me just write this example: 1 2 5, 1 2 5, 3 8. This is your profit, this is your loss, and this is your good. So there is just one good guy. So what happens is, your profit can't satisfy this person, so you pair profit with good. So these two are gone on day one, so your count is 1. Now on the next day you see this is a profit guy. This still can't satisfy this guy, and there are no good person left, so you just pair these two up, and your count is 2, and that is your answer. Okay, now there are multiple methods, but this is the way which can generate the answer every time. This is the way which generates answer every time. Okay, this will generate every time. Now you can be like, okay, first we'll pair these three, and then we'll pair these two. Yeah, this is also possible. We can do multiple pairings here, but the But the constructive algorithm is such that we do the following pairing. Okay, 1 second. Yeah, is my screen visible? 1 second, I'll just share it. Yeah, okay. So yeah, I was telling this that this will work every time. This will work every time. Now let's just look at the code here. The code is such that first we input n is the number, n is 1 second. First, what we'll do is we'll input n, the number of friends we have. Then here we'll have xi and yi. That will be the inputs. So that's how this is the input xi and yi. Then this is your vector loss and this is your vector profit. The term here I have mentioned as good, but in my code I've written it as useless. Like they can be paired with anyone. So initially what we'll do is if your xi is greater than yi, then you'll just put it in the loss. They are the loss people. If it is xi is less than yi, they are the profit people. You'll just push back the profit that they generate. Else you'll just push useless plus plus. You'll just maintain the count of how many people are such that their xi is equal to yi. Then you'll sort both these arrays. Then you'll declare your initial answer as 0. You will no need to do this, but yeah, I've stored the size of the loss and the profit, number of people who are generating loss and number of people who are generating profit. Then these are the two pointers. These are the pointers that I'll be maintaining. Like how many profit people have pushed out, how many people who generate profit have visited the restaurant, so that I don't mention their name again. So IL is the number of lost people, IP is the number of profit people who have visited the restaurant. Okay. Now, while IL is less than size L and IP is less than size P, like till I either completely finish my loss people or till I completely finish my profit people. Profit people are the people who are generating profit. Loss people are the people who are generating the losses. Till then, what I'll do is I'll just if my okay now check this out. If the topmost position, okay, if your if your loss guy, okay, this is your loss array. 1 second. This is your loss array and this is your profit array. So here there is some number, say x, say the number here there is some number a, and here there is some number b. So if a is greater than equal to b, it implies I can pair this up, right? I can pair them up. A is the profit generated by the person, b is the loss generated by the person. If profit is greater than equal to that, then I can pair them up. If a is less than b, then what I'll do is I'll check if there is good person. If there is good person, if there is good person, I'll pair a and good person. I'll pair a and good person together, right? Now if there is no good person, okay, if there is no good person, then I'll just pair a with one more a dash. Like a dash should be here below this, b dash, like a dash, a double dash. So these are the people, one, second, third good person, where a double dash is greater than equal to a dash greater than equal to a, because we have sorted this, right? We sorted this array initially. That's why this is how it will look. So yeah, we can look at this code here. This is how I coded it. If this is less than, if your a is less than, if your a is greater than equal to b, then what you'll do is you'll just put them, you'll just pair them up. So one pair has visited the restaurant, then one you'll increment il, which is the number of people, number of lost people who have visited restaurant, and number of profit people who visited restaurant, because this is the case where one lost person and one profit person visits the restaurant. Else, like this is not possible, like profit person is not able to satisfy, then you'll check if there are some good people. If there are good people, what you'll do is you'll pair them up with the profit person. So your one profit person visits, and your number of good people will reduce because you have paired one good person, right? And your answer will be plus plus, because your answer will be incremented by one, because one more pair has visited the restaurant. Else, Else what you'll do is you'll check if you can, you'll check if there is a possibility of, like, if you have two profit people or not. Like if you don't have two profit people, then you'll just break from the loop. Okay, like you need two profit people. Like suppose there are some 1 2 3, and here there is some 1 1. Okay, these are the losses generated, these are the profits generated, there are no good people. So first you pair them, first you pair these two. Okay, first you'll pair this because you can satisfy, this can satisfy him. Then you pair 2 and 1 because 2 can satisfy 1. This is your profit, this is your loss. Okay, now this is a profit of 3. So based on algorithm, you can't pair it with the loss because there are no loss. You can't pair it with the good because there is no good. So you'll answer plus plus only if there is one more profit person to pair it up with. So this condition is put in here, like if IP plus 2, like if there are at least two people in your array left. So if there are at least two people left, then you'll increment your answer, and you'll increment your people, like profit people who visited, by 2 because two of them went, right? And if nothing of this is, if nothing is possible, then you'll just break out of the circuit, break out of the loop. Okay, now after breaking out from the loop, okay, if your if there are still some profit people left, okay, if there are still some profit people left, once again I'll just explain. Yeah, if there are some, there's still some profit people left. Okay, so let this be a profit array, let this be the good count. If there are still some profit people left, what you'll do is you'll pair the profit people up. Okay, so first thing you'll do is you can randomly pair the profit and the good people. So the number of people who are left in the profit plus the number of people who are left in the good by 2. This will be the number of pairs that are possible. Number of pairs that are possible, right? Now if there are no profit, if there is no profit, like, then in this case what you'll do is that will be number of good people by 2. You'll just add this to your answer. Answer plus equals to number of good people by 2. So number of good people who are left will be, suppose there are some 10 good people left after all these loop operations, then you can just make 5 pairs out of them, and there'll be 5 extra, your answer will be incremented by 5. And suppose there are some 10 good people left and some 4 profit people left. Like suppose you exhausted your lost list, like there were 4 lost people, some 10 profit people, and some good people. Okay, in this case what you can observe is that your loss will, one second, I'll just give a good example here. Suppose you have some 4 lost people, and suppose you have some, this is your loss, this is your profit, and this is good. Okay, so suppose there are some 5 good people. Now this is your profit people who can generate profit. So in this case you'll pair this up, you'll pair this up using the algo, you'll come till here. Now when you are here, what you'll do is as soon as this gets exhausted, like you finish off your loss, right? So you'll come out of this loop. You'll be out of this loop because IL will be equal to size of L. Now since this becomes true, you're out of the loop and you're left with some profit people and some good people. Now if you're left with some profit people and some good people, there can be two cases. Okay, either you are left with some profit people or there are no profit people. If there are some profit people, then you'll increment your answer with profit people plus good people by 2. Otherwise, you will just increment your answer with good people by 2. Okay, because if the other case would be that there are some lost people, there are some profit people, and there are some good people. Suppose there are some 10 good people. So you can pair these with the good peoples, and your 7 good people will be left. 7 good people will be left, and then here you have your loss. You have IL not equal to loss. Okay, size of loss. But in this case you can't pair this up with anyone. Okay, because someone has to pay their bill, but these people, the good people, can only pay for their own bill. So there is no one to pay for them, hence there will be no pairing here. So you'll just pair these up, you'll just pair the good people up, and the number of pairs would be g by 2. Okay, the integer answer of g by 2, basically the floor function of g by 2. And here also the answer is floor function of p plus g by 2. So this is how the code is. Here you can see, after when we come out of the loop, if there are some good people left, If there are some profit generating people left, then we add we add the good people, and these are the number of like size. Okay, the size of the array, size of the array of good people minus the current number of good peoples that left. Okay, so total number of good people is the size of the array, right? And ip is the number of the good people who left, so then the remaining good people is size p minus ip. So these are the number of good peoples. This is the number of oh my bad, this is the number of profit generating people who are left. This is the number of good people, and this divided by 2 will give you will be added to the answer. If there are no good people left, like if ip is equal to size p, then in that case you'll just add the number of good people, and then you'll just see out your answer. So this is the solution, and this is the explanation for this code. Now I hope you understood this. So now let's start with problem E. uh, I have opened the problem E here. The problem E is such that there is a random cycle of size n. Now a cycle is defined as this. Now this is a 6 vertex cycle, this is a 5 vertex cycle, and this is a 4 vertex cycle, and so on. So a cycle is such that there are n vertices and n edges. Okay, n vertices and n edges, and the order of vertices is random. Order of vertices is random. Like this could be 1, 2, 3, 4, 5, 6, any order. Okay, any order, and it will still be a cycle. So this is the definition of a cycle. Now here it is given that if we give a query ij, the interactor will give us an output of path length I to j. Now in cycle, in case of a cycle, there are two possible path lengths. Like suppose I give you a cycle of length 5. Okay, let's make a simple cycle 1, 2, 3, 4, 5. Now if I give a query 1, 2, the possible path length is 1, and the other possible path length is 1, 2, 3, 4. Yeah, this path. Okay, there are two possible path lengths, which is 1 and 4. So the probability in the question they have stated that the interactor is implemented such that, okay, one second, yeah, the interactor chooses one of the two paths with equal probability. Okay, so the probability that it will give this answer is half, and this answer is also half. Now, one more thing mentioned in the question is, like if I ask this 1, 2 again, the answer will be same as previous query. Okay, so asking the same question again won't make sense. But if I ask it in the reverse order, the answer may be it may be answered differently. Like question 2, 1 will give the path length between 2 and 1, and here also the path length will be 1 or 4 with a probability half and half. So the probability that question mark 1, 2 is equal to question mark 2, 1, like the path lengths are equal, path length answers are equal. What is the probability of this happening? So probability of this happening would be either 1, 2 gives answer as 1, 2 gives answer as 1, and 2, 1 also gives answer as 1. Like this is both give answer is 1, plus the case where both give answer as 4. Okay, either they'll both give answer as 4, or they'll give both will give answer as 1. So this is both answer equal to 4. This overall probability is half. Okay, now we are allowed to do 50 queries, right? We are allowed to do 50 queries. So what we can do is we can ask 1, 2, 2, 1, we can ask 1, 3, 3, 1. Okay, and we can so on, we can ask 1, 27, 27, 1. So these are 50 queries. Okay, these are 50 queries. Now the interesting thing is, suppose we'll go in the order. Okay, we'll ask from 1 to 2, 1, and so on. We'll follow the order to 1, 27, 27, 1. So this will be followed in the ascending sequence. So if for some query we get answer as -1, implies that n is not possible. Suppose this occurs for n equal to 4. So we know that n is not 4, n is less than 4, but since it did not output -1 for n is equal to 3, we are going in ascending order. For the first time we encounter -1 at n equal to 4. Okay, if this is the case, then we can for sure say the answer is n equal to 3, right? Because it didn't output -1 for n is equal to 3, and for the first time we found it at n equal to 4. Okay, the other case would be that we didn't get minus 1 at all. Okay, we do not get minus 1 at all by iterating from 1 to 127. Okay, so we for sure know n is greater than 27, right? Now in this case, what will happen is, for 1 2 and 2 1 to give the same answer, the probability is 1 by 2, right? Now for 1 2 2, okay, one second. For 1 2 2 1, 1 3 3 1, and all these queries till 127 27 1, for all of them to give different answer, the probability would be 1 by 2 raised to 25. Okay, like each has a probability of half of giving same answer. So half into half and so on, like this will be half 25 times, right? So this is a probability that I'll get the same answer every time from the interactor. Like same answer as in 1 2 will be equal to 2 1, 1 3 will be equal to 3 1, and so on. Now if 1 2 is equal to 2 1, like question mark 1 2 is equal to question mark 2 1, then I can't decide the path length. Then I can't decide the path length, right? But if it is not equal, what we can notice is this. Suppose this is my graph. This is some random two vertices. So the path 1 length will be this length, and path 2 length would be this length. So the path 1 length plus path 2 length is equal to n. We can see this for sure, right? The length of the path 1 plus the length of the second path. So these both add up to n. If they are not equal, if they are equal, we are not sure. Okay. If they are equal, then it might be the case where this is the path length. Like for example, if I have 1, 2, 3, 4, 5, and 6. So if I put 1, 4, the output will be 3. So if I come from here, the answer is 3. If I come from here, the answer is 3. But I'm not sure. But I'm not sure if but it's not sure that having 3 will mean that I have a path length of 6, right? So if path 1 is not equal to path 2, if path 1 is not equal to path 2, implies path 1 length plus path 2 length will be equal to n. So this is how you find n. Now the probability that path 1 is not equal to path 2 for all the 25 queries. For all the 25 queries. What's the first query? First query will be 1 2 2 1. This is my first query. 1 3 3 1. This is my second query. And so on up to question mark 27 1 and 127. So these are my 25 queries. Now the probability that path 1 is not equal to path 2 for all the 25 queries will be half into half and so on into half, right? So the probability that path 1 is not equal to path 2 for all the 25 queries is 1 by 2 raised to 25, which is like basically almost 0, right? So there is almost a 0 chance that for all of these the answer will be 0, like the path will be equal. Hence, if you just look at my code is just asking it the value of 1i and i1 from I is 2 to 27. Now, if my x is not equal to y, if the paths are not equal, you just output x plus y. Now, x plus y in this case will be n, and you return. If either of them is minus 1, like the first case I discussed, okay, the first case I discussed here, which is this case, okay, if either of them is minus 1, like this, that is if n is less than 27, if n is less than 27, then we look here. Then what happens is, if n is less than equal to 27, yeah, in such case what will happen is we'll just output n x minus 1. Like suppose we encounter a minus 1 for some x, for some I, okay, for some, say I equal to 5, we encounter a minus 1, then in this case we can see that n cannot be 5. But since we didn't get a minus 1 at n equal to 4, this implies the value of n is 4. So that's why we just output I minus 1 here. So that's it. Like this is the code for the E question, and yeah, I hope you understood it. Thank you.